You ever stop and think about what your computer is doing right now? I mean, you've probably got music streaming, maybe a dozen browser tabs open, notifications popping up, and it all just works. It feels like magic, right? Well, it's not. And today, we're going to pull back the curtain on the two super important concepts that make it all possible: processes and threads. Let's get into it and see how the real magic happens.
So yeah, it's this incredible magic trick, this seamless illusion of doing everything at once. But behind that performance, there's this brilliant system, and it's all being managed by the boss of your computer, the operating system. So the big question is, how on earth does one single machine juggle all that stuff? Well, the answer is actually going to change the way you see your digital world. And it all starts with a really simple but powerful analogy.
Okay, here's the key that unlocks this whole thing. I want you to imagine your computer's operating system, the OS, as the CEO of a gigantic company. This CEO, they manage everything, every single project, every resource, every last employee. If you can keep that picture in your head, I promise the rest is going to click right into place.
All right, so in our big company, before any work can actually get done, you need two things, right? You need the blueprint, and you need the building itself. And that brings us to our first major player, the process. So first up, you've got the program. A program, like the code for Chrome or Spotify, is basically the architectural blueprint for a new company building. It's just a set of instructions, sitting there on your hard drive, totally passive. It's not doing anything yet, it's just the plan.
So what happens the second you double-click that icon? Well, that's when the COO, our OS, grabs that blueprint, brings it to life, and it becomes a process. It's not passive anymore. Now it's an active entity ready to get to work.
So, sticking with our analogy, a process is the company building itself, fully constructed and open for business. When you launch, say, your web browser, the OS has basically just built a dedicated browser company building. It used the program's blueprint, and it's given this new building all the resources it needs to operate completely on its own.
Okay, so what exactly makes one of these company buildings so self-sufficient? Let's take a peek inside and see what kind of resources a process gets all to itself.
So, think of it like this. Every single process gets its own private, totally self-contained building. Inside, you've got the tech section, that's the company's rulebook. You've got the data section, think of that as the shared office supplies. The heap is like an expandable warehouse, and the stack is like each department's temporary whiteboard. But here's the absolutely crucial part. These buildings are completely separate. What happens inside the browser company stays inside the browser company.
Okay, a shiny new company building is great and all, but it can't do any work by itself, can it? You need employees. And that, my friends, brings us to our second key concept: threads.
So the official kind of nerdy definition is that a thread is a single sequence stream within a process. You'll also hear it called a lightweight process, and that's a good way to think about it, because it's basically the smallest possible chunk of instructions that the OS can actually manage. So let's go back to our company. A thread is an employee. It's the actual worker bee who takes the company's resources and gets the job done, right? The process is the building with all its stuff. The thread is the employee doing the work inside that building. And here's the thing you got to remember. A process is pretty much useless without at least one thread. I mean, an empty office building doesn't get a whole lot done, does it? Now, this is where things get really efficient. All the employees, all the threads, working inside the same company building, well, they share the main resources. They're all reading from the same company rulebook, the code section. They're all using the same office supplies, the data section. And they're all connected to the same company server. Because they're all under one roof, they can talk to each other super fast. It's easy. But even though they share all the big stuff, every employee still needs their own private desk, right? The program counter is like their current to-do list item. The register set, that's their personal calculator. And the stack is their own notepad and their coffee mug. This private little workspace is what lets each thread focus on its own job without getting its wires crossed with the person at the next desk. So who's the manager for all these employee threads? Well, it can work two ways. First, with user-level threads, the application itself is the manager. It's super fast, but there's a big catch. If one employee gets stuck, the whole company can grind to a halt. Then you have kernel-level threads. This is where the big boss, the OS itself, is the manager. The OS schedules everyone, which is way more robust, but it does mean a bit more paperwork for the CEO, a little more overhead. And all of this leads to the big design choice, the critical question for any software developer. When you need to get more stuff done, do you build a whole new company branch, a new process? Or do you just hire a new employee for the building you already have, a new thread?
To see how this plays out in the real world, let's talk about something you're probably using at this very moment, the Google Chrome browser. Its entire design is a perfect example of this choice in action. So Google made a pretty famous and, at the time, really bold choice. See, most browsers back then treated a new tab like hiring a new employee, just adding another thread. But the Chrome team, they decided to treat every single new tab like it was opening an entirely new company branch, a whole new, separate process.
And this table just lays out that core trade-off perfectly. When you make a new process, our new company, it has its own separate memory, which is super safe and isolated, but communication is slower. On the other hand, when you just hire a new thread, a new employee, they share memory so they can work together really fast. But, and this is a huge but, if one thread crashes, if one employee makes a catastrophic mistake, they can take the entire company down with them.
So why does Chrome's choice matter so much to you? It's all about stability. If one of your tabs crashes, if one of those company branches goes completely bankrupt, what happens? Nothing. Your other tabs, those separate, isolated processes, they just keep chugging along, totally safe. That's why one buggy website doesn't crash your entire browser anymore. That single design choice makes your whole browsing experience way more stable and resilient.
Okay, so we've got companies and employees, blueprints and buildings. It's a fun analogy, but why should you actually care about any of this?
Here's why. If you walk away from this with just one thing, let it be this quote right here. Threads share memory. Processes do not. That's it. That one single difference is, well, it's everything. It's the fundamental trade-off between speed and stability, between risk and safety, that defines pretty much how all modern software gets built.
And now you have the perfect way to think about it. The next time some app on your computer freezes up or one little browser tab crashes, you'll know exactly what's going on under the hood. You'll be able to ask yourself, was that just a single faulty employee, a thread that caused a little glitch? Or did the whole company, the entire process, just come crashing down?